Hello, everyone, and welcome to today's webinar, a step-by-step guide to securing large language models. Before we get started, I want to cover a few items so you know how to participate in today's events. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send your questions in at any time during the presentation, and we will collect these questions and contact you after the webinar to respond. Today's webinar is being recorded, and you will receive a follow-up email within 24 to 48 hours with a link to view the recording. I would now like to introduce today's presenter, Ravi Aital, founder and CTO for Normalize. Ravi, over to you.
Thank you, Stacy. Hello, everyone. Welcome to this webinar on step-by-step guide to securing large language models, which seemed to be the craze starting about last year around this time. So a lot of our customers ask, how should I think about securing AI? How does it work? What are the security implications and so on? So this is our attempt to be helpful in that regard. So first off, let's start with a couple of fun facts, right? So there are about 1 million custom applications, in the Fortune 2000 companies. You might be wondering that's a tad too much, but these are backed by, this is an estimate, of course, nobody really has counted every single one of them. Cloud Security Alliance, about 3 years ago, did a survey. It found that on average, there are 500 custom applications in each of the Fortune 2000 companies. 500 times 2000 is a million. It's mind-boggling. So what do you expect when there are 1 million custom applications in Fortune 2000? All of these applications, what do they have in common? Developers who are hungry to add value to these applications, right? And what is the one thing on all the developers' minds? It's AI, right? Every single one of them is ready to be sprinkled with some AI magic over the course of the next few years. So just with those sheer numbers, as security professionals, it behooves us to go and figure out what does it actually imply? What does it mean to have AI sprinkled into these million custom applications? It's not all bad. On the flip side, AI can contribute up to 15.7 trillion to the global economy by 2030. This is a result of a research study by PwC. It could be a trillion here and there. It's not a big deal, right? So 15.7 trillion is too large a number to be ignored. And a lot of these, this efficiency, this contribution is going to be delivered by adding workflows and additional workflows to existing applications as opposed to creating brand new applications, which also could happen, by the way. It could replace humans in a bunch of menial jobs or low value jobs. But at the same time, existing applications and new applications that use LLMs are going to make up a huge portion of this $15.7 trillion. With those numbers in mind, it is good to actually go into learning about how these operate. Let's start with a brief introduction to what LLMs are, what LLM applications are, how LLM security is different from traditional security, what could be a good framework for securing LLMs, how do we implement those, and then we'll summarize at the end. So let's start with the introduction. So let's start with the definition of what a large language model is. Whenever there's a brand new technology, as engineers and technical folks, we get into the details of how does this work, that work, and so on. So there are so many details. The cognitive load is too much. For someone to actually step back and then look at this as a black box and protect it, right? So if you have to wait until we analyze and understand everything that's going on within an LLM to protect it, it's too late, right? Because there's always somebody who's willing to take advantage of the first vulnerability they find before going into details of hey, is this vulnerability really applicable or not, right? So you need to always step back and then understand LLMs at a black box level and then go from there. Let's attempt to do that. So the best definition I've heard may not be the best, but one of the definitions that I liked is to treat LLMs like any other library, right? So it could be AI, it could understand language and so on, but at the end of the day, you send it a request, it gets you a response, right? With various other things that make up what it is. Another definition I heard was think of LLMs as a smart database. The reason is that human language and data about the real world and anything that you're talking about are somewhat inseparable. There is no language without data. No, and data has to be expressed in terms of language, which is why you can think of this as a black box, as a module that can understand, interpret, and generate human language at scale, and that requires holding a lot of data within it, right? So, what does an application that uses LLM look like? Before we understand that, let's build a model of what a traditional app look like in its most basic form. You have some public and private data, you transform it, put it into a database, and at runtime, a user sends a request to the application stack, which sends a query to a database, gets a response, and sends it back to the user. And this query and response might happen multiple times. There could be multiple queries, multiple databases, and you could chain them together. You could slice and dice and whatnot. But at the most basic level, the user's request is translated into a query, you get a response, and send it back to them, right? With, of course, all the business logic that goes into the application stack. If you take an LLM app, a basic LLM app, it's very similar. Instead of the database, you have training and the LLM itself. You have the public and private data, you transform the data, turn it into trillions of tokens, which you can use to train an LLM, which is then kept as an entity that can answer questions that come at runtime. We call them prompts, and the responses go back to the application stack, similar to like how the responses from a database would go back, and that's conveyed back to the user. Again, very similar to traditional apps. You could have multiple prompts and responses. You could collect them. You could slice and dice and massage them. But in the most basic form, this is how it looks like. Of course, it's a little bit more complex, especially when it comes to enterprise apps where there's a lot of private data. So instead of creating a brand new LLM with every single copy of private data, every single instance of the enterprise, what usually happens is at runtime, when the request is sent by the user, the application stack retrieves relevant data for that particular request using something like a vector database and takes that set of data, appends that to the prompt, and then sends it to the LLM so that the LLM can now understand in natural language the prompt and the relevant context in terms of the documents. It can tailor the response for that enterprise in its response, which the application stack can send back to the user, right? So this is roughly the model. So you have the public data, you have the private data retrieved at runtime, which is sent to the LLM. Responses are based on both the prompt as well as the private data, right? So that response is sent back to the user. Now, what makes LLMs revolutionary? Why exactly? Isn't it just like any other database? The biggest advantage is the unprecedented accuracy in natural language understanding, which basically makes it almost human, right? And it can follow instructions. So, in that fashion, it's probably better than humans. Sometimes humans don't follow instructions. So with that, you get almost sort of like, let's say you're in engineering, you get a junior engineer. Let's say you're in finance, you get a junior analyst. Let's say you are in law, you get a paralegal, almost, right? So that's kind of the level at which the LLM can operate. And can go beyond text, but that's outside of the scope of this talk. But really, the human-like understanding the context and the nuances, even slangs and humor, and being able to learn things over time using these private documents, as well as when there are updates to the underlying LLM itself, is what makes it revolutionary, right? And why is it hard to secure? Why are we even talking about it? Isn't it like any other application? The biggest issues are data privacy and confidentiality, because you generally train or like and get answers from an LLM by dumping a whole bunch of data. That's kind of the modus operandi. That's also the beauty. That's also the downfall of using LLM to interpret data for you, your enterprise data for you. The volume and the variety and general reliance on unstructured data makes it super hard to control what data is being seen when you're training or fine tuning or even answering questions um, without a lot of effort, right? And there is dependency on external data sources. There's a lot of data that, like I said earlier, in order to learn the language, you need data to go with it, right? And that already brings in all the biases and potentially manipulative scenarios. And another issue is that you have data built into this LLM. So if someone were to steal this LLM from you and reverse engineer, they get access to all the data. The model itself could be stolen. And in general, what makes it hard is these LLMs cannot be introspected. You take a traditional database, you can probably, even if it contains hundreds of millions of entries, you can enumerate everything that's there, take it out, look at whether you want that to be there or not, and delete it. You can manage it piece by piece. But you look inside an LLM, they're just a giant set of numbers. There are billions of parameters. These parameters are nothing but numbers. You look at the numbers, you can't really tell it's sensitive, not sensitive, because all of that, they're like your neurons that hold a whole bunch of information, and no one neuron can actually be attributed to a piece of information. They make all of them are together, or none of them work, right? So at the end of the day, one more thing to keep in mind as a segue is they're approximating this human layer, semantic layer. So you cannot arguably come up with all questions you can ask a human. So it explodes the surface area of all possible attacks. So that makes it super hard to secure. So you could think all of these are theoretical. There are no real exploits and whatnot. But just like, internet happened, like, all the attacks were all theoretical at that point. Over maybe a decade or so, they became super real. And cloud came along, and that was all. There was a lot of attacks that could happen on cloud. They were all theoretical, and now we see attacks on the cloud on a daily basis. Social networks came along in a different way, right? So there are attacks on the society itself, the way we communicate, way we interact with each other. There is attacks on that, and attacks on our collective conscious in social networks. So when a new piece of technology comes in, we in the security community, we need to like get our act together to be prepared, and then see how we can protect it. Just to make it real, though, I'll present you with an example. Last winter, I was shopping for a sweater, and this is my mobile app, screenshots from my mobile app. One of those days, I went to Amazon. I was looking at some of these reviews, and it says AI generated from the text of customer reviews. And then right up there was something about, hey, are you looking for specific info? So on a whim, I asked, just like I make things, I want to break things. So I asked, hey, write me a reverse shell in Python. And I was expecting Amazon would say, hey, no, I can't do that, or something like that. But lo and behold, it just gave me this whole uh, program, and even started explaining it. And it's not so innocent, because it's talking about attacker, victim, and so on. So it knows that this is stuff for hacking. Yet it went ahead and gave me that in a customer service app, right? And it went on and on. But essentially, like, if you really look at it, would a customer service rep, if you were to have a customer service rep, would he have done this? No. So humans are generally more intelligent, right? So that's where we need to think about how LLM security is different from traditional app security. For that, let's refer to the good old OSI model. The analogy with the postal service. You have the physical delivery that is done on, with envelopes. There are sorting centers that are similar to, like, our networking layer in the OSI layer. You have transport layer, which is, kind of postal standards and guarantees and retries and 3 times retry and whatnot, which is the transport layer. And you have the mail tracking, which kind of tracks the session layer. The formatting is the presentation layer. Communication is the real application. Two people are trying to communicate. But at the very top, you have memories and thoughts in human minds that they are using to communicate with others, and all the lower layers come into picture. In the OSI layer model, in the OSI model, the top layer is the human, and in the LLM app, that layer corresponds to the semantics, right? So if you really look at data and the analysis, they are the ones that define that human layer. So you could expect, okay, so there must be some commonalities here. Let's see what type of protections we have against other layers. See if that applies to the human layer. So at the basic layer, if you have cables and signal, somebody could physically tamper it. So you have the physical security systems and cameras and the thick layering around the cable and whatnot, right? Then you have snooping that's possible by leaking frames. So you have the NAC and link layer encryption. Then to avoid MITM attacks at the IP layer, you have ACLs, and so on and on and on, right? So until you get to the application layer, where we started seeing the introduction of, let's say, web application firewalls and CASBs and IPS. That's kind of where the application stack has stopped, right? And nothing has been done for the semantic layer, data layer. Of course, there is data scanning and whatnot, but really, how does that really look like? What are the threats and what are the remediations? Which is where it's probably worth comparing humans and LLMs and see how they're different. Because if you can compare a human to an LLM, maybe we'll know what the threats are and then how we can remediate. But again, while they operate similarly, there's a lot of differences as well, right? So humans are slow, LLMs are fast. So anything that humans do, for example, if you went and asked a customer service rep, hey, write me a script in Python to do a reverse shell, he's intelligent enough, right? Generally, he's trustworthy. His little power, he may or may not be able to do it, but he's generally responsible. He or she is generally responsible. Say, hey, this is a customer service app. Why do you want me to hack you? Be a hacker for you, right? So that thing is built in, right? And also training and security policies are really effective because humans have a lot to lose. If you do some mistake, the HR policy can come in and then they can probably tell you, hey, don't do this or you're out of your job. There is no such thing for LLMs today, right? And humans can generally keep a secret. You ask, what's your mother's maiden name? Humans generally don't. I'm not going to tell you that. LLM, by default, it knows. It'll probably give you an answer, right? And in general, there is an implicit code of conduct as part of being brought up in the society and understanding what it means to be a business, what it takes to earn a livelihood. There is an implicit code of conduct which is lacking in LLMs, right? So because of all of these threads, researchers found a bunch of, there's a series of papers on what these threats are. It could be on confidentiality, leaking data, figuring out who is part of what, membership inference, gradient leakage, which allows you to take the model itself out, and in general, RBAC, beating RBAC, getting access to something that you should not have access to. Integrity of the data itself, things like feeding data, it started happening even with SEO a little bit, then it started happening with many other semantic search engines as well. Manipulating the model, you can see that a lot in things like Yelp and so on. Fake news, adversarial attacks, like showing something that feeding just a little bit of information, it could be trying to beat a facial recognition application and so on. And in general, availability, because AI applications are resource intensive. You could try to trigger a DDoS or a denial of service or resource exhaustion, right? So given all of this, how do you go about securing? You could think of, hey, let's take each of these attacks one by one. Let's see how to prevent it. But this would be akin to in the previous world, like when you were trying to protect your servers against different attacks. You don't want a product one by for every single vulnerability that's out there. Yes, there could be a signature. Hey, I just need to find this particular field in this particular um, this particular pattern in this particular field, and then I can avoid this particular attack, right? But there are thousands of those, right? Today, we don't have thousands of LLM attacks, but there are hundreds of classes of attacks, maybe dozens of classes of attacks. So you want to build a framework by which you are prepared to identify those attacks and then prevent them on an ongoing basis. Today, I'm going to focus more on a couple of these aspects, but in general, give you a framework for securing your LLMs, right? And to do that, let's take a black box approach. So this is the model that we talked about earlier, right? You have this model where data is coming in, it's getting fed, like trained and fed into an LLM. You have the prompt and the relevant documents getting fed into LLM. Response goes out, right? So we talked about this earlier in this presentation. If you really look at the black box LLM, let's enumerate the interfaces. Now you have the training data that's going in. You could sanitize that training data, right? And you could sanitize the retrieval augmented generation RAG data that is coming in at runtime. You get a prompt and we pull the relevant data from your, it could be your enterprise data store, and then we feed it into the LLM. So you could sanitize the data there. You could sanitize the prompt itself, and you could sanitize the response, right? Actually, it's not just good, but you should, right? So all four of them are required because these are the pretty much at a very high level exhaustive interfaces into your LLM. And how do you go about doing that, right? This is where the step-by-step guide comes in. Even before you do this, like you probably want to identify how many of those 500 average number of applications that you have in your enterprise are actually already using LLMs, right? So step number one is to discover all your apps, LLM apps within your organization. And then for each LLM, protect all the lower OSI layers using traditional technology. We're not going to go into details. Like you can use your entire application stack that is there today. What is important for this talk and this concept of securing LLMs and using securing AI in your apps is what goes above it in the semantic layer, which is protecting the training and RAG data interfaces and protecting the prompt and response interfaces. And let's dive into it. So how do you discover LLM apps within your organization? Fairly simple. One thing could be, even without any technology, what you could do is go look at your cloud bill. You'll be able to see in your AWS who's using Bedrock, in your Google who's using Vertex, in Azure who's using OpenAI, the teams that are using it. Today, it's very minimal. So probably like, a handful of teams. Even then, this is not a repeatable process, and pretty soon you'll be bogged down by it. So you could do that today, right? So I encourage all of you to go take a look at your bill, and then see who is using it, which accounts are using it. Go talk to the account owners, and then learn about how they're using it. That you will learn a thing or two. Second is like if you want to automate it, which I think you should get on very soon because we are seeing plenty of developers. It could be for experimentation, it could be for already deploying in internal environments, or maybe even in production. They're already using these cloud provider based APIs, right? People are usually not, especially in like enterprises for applications, they are generally not building their own LLMs. There are a few teams that do, but mostly they just use off the shelf LLMs and then use the training data and provide that interface to the existing apps. So what you could do is you could use a cloud provider provided APIs to list all these AI services, trace the resources that are using the APIs, and also trace what resources the APIs are using. Like if you have Bedrock, it can be connected to an S3, it can be connected to an RDS, and so on. So you could trace all of those, and also the owners, right? And then once you get this map, you will know what type of data is flowing into LLMs and who are using it. And at that point, your focus can shift on what is this data, what's in this data, what am I feeding my LLMs, right? And by the way, my company Normalize can help you with that aspect. It can give you an inventory of all the LLM applications. Now, coming to the protection of LLM interfaces, if you look at the layers, based on the CIA triad, confidentiality, integrity, and availability, typically for confidentiality, you would want to scan for sensitive data. The training data that's going in the retrieval the data that you're augmenting the retrieval with, and the prompt and the response. You could just scan for sensitive data with appropriate building blocks and match some policies, and you can fit that into your architecture. Let's go into that. Like a lot of these boxes have uh, similar building blocks, scanning for sensitive data and matching the policy, right? And it's fairly simple when you break it down this way. So first building block is a data store scanner. You have a data store, and you could use data store security posture management, DSPM. That's what we specialize in, Normalize. It's very simple. Connect a data store to DSPM, It'll scan all your data. You can sample and whatnot, but you can scan all your data, and you can post process it by redacting or maybe just eliminating that from a virtual data store. And you have a data store now without the sensitive data, right? And you can decide what is sensitive for you. It could be your IP, it could be your customer data, it could be your employee data, PCI, and whatnot, right? But the main idea here is to use a DSPM. You could tag all these objects and then retrieve only the objects that don't have the tag to give you a virtual data store that does not have sensitive data. Then you can use this for both RAG and training and whatnot. The second building block is an on-demand document scanner. This usually applies to retrieval augmentation. If you have a document, you can use a document scan API or a DSPM. That's what we provide as well, to figure out whether it contains sensitive data or not. If it does contain sensitive data, you can redact it or remove multiple copies of it and then use it, or you can just discard it. If it does not contain sensitive data, you can go ahead and use it. So it's fairly simple, just a simple flowchart, uh, if else condition. So you can implement this. The third one is very similar. In fact, it's a subset of the previous one, on-demand text scanner. This is what you can use on regular text so that you can apply this to your prompts and responses. Now, once you have that, it becomes very easy to protect the data layer, right? So this is our diagram, that the model that we are working with. It's fairly simple to start adding these building blocks in the appropriate flows so that you can go and protect it. So in the training and fine-tuning data, you can use a data source scanner. So whatever you're feeding the LLM or fine-tune, for the training or the fine-tuning phase, you can create that virtual data store that does not have sensitive data and feed that to the LLM. During retrieval, you could use the on-demand scanner, on-demand document scanner, to only retrieve documents and augment with documents that have no sensitive data. And at the query phase, you can use the on-demand text scanner, same in the response phase as well. You don't want to feed the LLM any sensitive data, and also you don't want the LLM to send out sensitive data back to the user that could potentially expose sensitive data. So both phases, because you don't know how the LLM is actually using that sensitive data. That might be a trigger to extract additional sensitive data. Right? So fairly simple, right? But what about the semantics? We protect the confidentiality, but what about integrity and what about all the other use cases? What's the keyword for biases? You cannot just look for biases using a DSPM, right? You could to probably 90%, but not the rest 10%. What is the regex for hallucinations? How are you going to avoid hallucinations? How are you going to detect model stealing, right? This is where the policy match building block comes into picture. So not many companies are providing it, but this is a fantastic opportunity for somebody to build a tailor-made LLM to serve this, right? You take a document or a prompt or a response text. I'm kind of generalizing it there, but you can apply an AI policy match API that says whether it conforms to the policy or not. One thing to keep in mind is, back in the day, like when you had every layer of the OSA layer coming under attack, the remediation also ended up using technology in that layer, right? So if you have a physical layer, you have physical security. If you have IP layer, you're operating on the IP layer in general. You started looking at application security, you had to go into the application layer and look at what's happening there. You go into data, then you start looking at data at rest. You go into now semantics, your solution has to use semantic capabilities to say, hey, what this user is saying is wrong. This user has a bad intent, or this particular response is not right. All of these things cannot be done using lower layer technologies. You have to use AI, right? So it becomes very simple when you look at it that way. You have an AI response, AI input or response, and you can use AI to see if it conforms to policy. Yes, use it. No, don't use it. When you go that way, it becomes fairly simple, right? I mean, at least in a mental model way. All you need is a policy library. All you need is a system that can enforce the policy, and you start writing those policies in natural language. You can say, I have this AI data usage policy. It has to comply with data protection laws. And the right LLM can actually understand all of it and then enforce it. Or maybe I can say data should be anonymized, and security should be treated as at the highest level, right? If you're so you can say things like, when in doubt, uh, give priority to anonymization, privacy, and security rather than serving the answer, right? So these are all things that you can express in natural language based on your policy. That would basically imply that that is what is happening in for remediation or protection in that layer, right? You could do the same thing with AI interaction policy. Like, what are the ethical guidelines for the interaction? What is the data privacy adherence guidelines, and so on, right? So at that point, what you need to do is create this policy library and then add one on top of it. You can tweak as you go. So there you have it. So in order to protect the semantic layer, it's very similar. Same insertion points. You use the data usage policy at the training and the RAG interfaces, and AI interaction policies um, at the query and response layers. Now, enforcing conformance to some policy is easier said than done, right? So the best practices to do this is to basically focus on simplicity, right? The more code you write, the more bugs there are. The more language you have, the harder it becomes to enforce it. So start with a simple policy and adjust it frequently, because at this point, it's just an AI that just takes it in and then enforces it. So you don't need to, you don't have a long cycle in order to implement this. Have this modularity so that you have a company-wide section and a department or application-specific sections, so that changing one doesn't affect everybody, only affects that department or application that is relevant. One of the things to keep in mind is also it costs a lot of money, and it's each check costs a lot of money. If you go to, for example, AWS or GCP or Azure, the guardrails or the PII check, they cost way more than it probably costs about 1,000 times more than it costs to just serve the answer. But over time, it's going to come down. I fully expect it to come down. But of course, you can fine tune an LLM with policies to make it faster and cheaper, right? That's very expensive. But if you're in a Fortune 100, a Fortune 500 company, you can probably afford to do it, right? So would love to engage with you and talk further on that as well. Now, what does modular policy look like? You would have an enterprise-wide policy where these are things that will be enforced across your entire enterprise. And you would have department, let's say marketing, all you might have some guidelines as to all your messages have to be brand aligned. For example, if you're using social media, you're using a tool to create content on social media, and you're using AI for that response can be sent through these set of policies to make sure that the messages are aligned with brand, it's accurate and honest, you're respectfully engaging with users and customers and competition and so on, and compliant with regulations and so on. So this gives you that framework whereby you can tune as you go. Right? Here are some examples. But at the end of the day, if you really look at it, the future is what I call a semantic firewall. And that's a combination of using a DSPM or a data scanner for inspecting data at rest, as well as matching policy at runtime, right? AI policies at runtime. It's as simple as this. Anything that flows through your system should conform to your AI policy, as well as data scanner. The data scanner, the DSPM has to say this is fine, right? That way you handle the integrity, confidentiality together, and that will lead us to protecting data at rest with the DSPM and data scanner, and in motion with the semantic firewall, which can front multiple LLMs. So you could just build this into a proxy, use an API like Normalize provides an API. You can use it, build it into your proxy, and then front all your LLMs with it so that your applications are sending requests to this semantic firewall, which is reverse proxying what is coming out of the LLMs. So there you have it. That's the end of the talk. What we learned today is that LLMs are a different beast slightly compared to traditional technologies because they approximate the human layer. And securing that is essentially securing all the OSI layers, of course, but most importantly, data and the semantics. And to do that, start with discovering all your LLMs. We call them shadow LLMs because security and IT teams are not even aware that these are being used. It's so easy to get started that you'll be a pile, suddenly you have a million developers that are experts in LLMs, right? So not in training or creating their own, but using it. It's so easy. So go and discover that today. And then use on-demand and full scans of data to protect your data layer. Then use AI policy matching to protect the semantic layer. You can do that in the next week. You can start auditing your LLM applications. We can help you. Talk to us. I'll post the contact at the end of this presentation. You can reach out to me directly, and we can help you, perform these steps. In the next 3 months, you can hope to understand where your data is, implement that entire data layer protection, and then start writing your AI usage policy. And in 6 months, you can implement the semantic layer protection. So a little bit about our company. We are funded by Lightspeed and Battery, very experienced team. Our category in which we operate is data security posture management, which you heard about a few times today, and the data proliferation and the explosion in AI usage is making us really valuable, as you can see in multiple customers across many industries, and lots of deep technology with 9 approved patents and lots of patents pending. Rapid time to value. You'll be able to see value in days, not weeks or months, right? So thank you for participating. If you have any questions, you can ask now and we'll reach out to you, or you can email me at ravi@normalize.ai. Do connect with me on LinkedIn or over email, and I would love to engage with you. Thank you for attending.